in ecological sciences. I'll talk about our involvement in the H2020, Horizon 2020 European IPM Works project, alongside other UK partners, LEAF and ADAS. So I'll give an introduction to the project itself, what we did over the last 4 years, including an example of putting IPM into action using tramline trials, and just touch on possible future for the project as it finishes up in the last couple of months until the end of March. So next slide, please, Dan.
Yes.
Thank you. So first of all, to introduce the project, we had a consortium of 31 different partners across 16 countries, and with the aim of using our existing farm networks, which LEAF was one, to create a base for new farmer hubs or farm clusters to appear. Similar to the aim of living labs, which often gets talked about at projects of this size, the purpose of this project was to show that integrated pest management really works in practice and on farm. And to do so, we did this by demonstrating IPM good practice, with the focus of the project being on agroecological solutions to reduce pesticide use as part of a holistic approach. Next slide, please.
Yep.
So the overall aim was based on the political aim in the EU when the project started, driving the delivery of 50% reduction in pesticide use within the EU by 2035. Now, that was rather ambitious of them, and it's, as well, we should note that the political landscape has changed a fair bit since then, since the beginning of the project, and this aim has been scaled back. But for the purpose of the project, each partner had to take this objective and relate it to their own regional context. So my job within the project for James Hutton Institute as project partner was as a hub coach. So like chair of young farmers, you had to lead this small group of farmers that you bring together and address some challenges. So for an East of Scotland hub that we're setting up, we had to take into account our regional context. The challenges being, and this is when I get to moan about the weather, so the short weather windows for sowing, spraying, harvest. We're luckier this year, and I don't think you've been so lucky down south. So I can sit and gloat this year, but usually not, because it's usually a wet autumn going into a wet winter, followed by a wet spring and into a wet harvest. So it's a long, cool growing season in a maritime climate that we're working with, and we're used to that. We can work around that. But adding to these challenges, we've got limited market options for the arable farming on the east coast of Scotland. So it's dominated by malting barley, which makes up 50 to 60% of the area. Then we've got winter wheat, some oats, oilseed rape, and potatoes, vining peas, and beans would make up the rest of the rotation. So we are limited in terms of what we can do with extending rotations. Next slide, please. So the first thing we had to do was bring together some farmers to address these challenges. So looking to the area of Perthshire, Angus and Fife, we're able to bring together a small hub of around 10 arable farmers. It fluctuated within the project between about 7 and 11 by the end, who were enthusiastic, open to trying new things and willing to learn through the process. And it was all about sharing at that point. So in the early stages, we sought to agree on objectives for the hub to address the challenges that we saw as being the major issues in farming in Scotland. The three we came up with were to test new or alternative techniques, which could be an agroecological approach or new technologies, to select practices to reduce inputs and maintain outputs, And that sounds relevant in terms of LEAF because that sounds very much like sustainable intensification. The third objective was always to focus on farm economics, because that's the crux of it. It's farming businesses that we're operating here. At the end and through the process of delivering these, we should also be sharing techniques and experiences to broaden the knowledge base for its members. And that comes out from the idea that I thought was more like a chairman of young farmers kind of idea, or like a discussion society. So we're there to share, and the knowledge exchange is happening all the time. Next slide, please. So now armed with objectives, and coming out from COVID, we were able then to set about project delivery with over 3 years, a programme of on-farm meetings as crop walks, farm tours or focus presentations, larger demonstration events with the project and hub represented at national events such as Arable Scotland and Potatoes in Practice. A couple of highlights there were machinery demonstrations, which gained a lot of interest through New Crop. Their new machine was demonstrated for electric home desiccation. I'm not sure if that's actually still continuing, but I need to get back in touch with them. There was also a steam weeding demonstration in another year in which we built our own steam weeder and used it on our site. So just points of interest that came up as new approaches. The third part of the project delivery was cross visits, which was a favourite of the farmers and a valuable activity for bringing the group together, actually, through networking and discussion created during these visits to other hubs around Europe. We were lucky enough to host the Irish and Dutch groups here at Dundee, and also had the opportunity to visit Tuscany in Italy, Carlow, County Laois in Ireland, and to the Flevopolders in the Netherlands. So it was a broad range of different regions, different farming practices, different farming systems, and a good cross-section of European agriculture. But what we did find was that there was much more that we could agree on than that we differed on, because we're all trying to do the same thing as farmers. Next slide, please. So within all this activity, often looked at the individual aspects of a farming system or individual techniques for demonstrations, such as the mechanical weeding, mulches, intercropping. But the real discussion and debate came when considering how these techniques all link together as part of an integrated farm management approach, again, as promoted by LEAF, in a whole system looked at holistically, or as a holistic approach in the whole. Regenerative farming, just as a side note, often uses this point to navigate scrutiny. So within a research project, we were looking to offer more solid data, suitable answers, and more certainty through use of these techniques. And can we assess performance of these individual aspects within a farming system, with the aim of improving the system as a whole on farm? So next slide, please. That's right, yeah. With help from ADAS, we made use of the opportunity to use in-field comparisons as a on-farm trial method. Facilitated by the hub coach, we provided these on-farm trials to test farm standards versus a new technique led by the farmer, but supported by the Research Institute and the hub coach and the project partners. This meant it was relevant to the context of the farm and could be done by the farmer either as a split field or as tramline trials. This method then allows us to facilitate demonstrations on the farm for the project and to share with others, but it also provides resources, whether that's time or expertise or scientific rigor, to test new ideas that may not otherwise have been available. So next slide, please. Looking at an example here, this is one of my favorite ones. as an agroecological approach. We had an infield comparison in Perthshire on a hub farm. If you like your horse racing, it's near Perth Racecourse, just for reference. The aim of this one was in an oilseed rape crop to reduce the risk of cabbage stem flea beetle. And I do realise that it's less prevalent in Scotland, but it was reported as becoming more prevalent over the last couple of years. So I wanted just to test this because I wasn't so sure that was actually happening. What we did was evaluate a companion crop establishment. Apologies.
Attention please, attention please.
Sounds like a fire alarm's gone off. We'll just give him a sec.
I think we're okay now.
Nice.
Apologies for that.
No.
So we evaluated a companion crop establishment with Tutarakum buckwheat and Berseem clover versus a farm standard of fertilizer and pre-emergence herbicide. And on the map there, in the centre, you can see that it's a split field design. In the centre of the field was our farm standard, which was the fertilizer and pre-em, and on the either side was the companion crop establishment. So you can see that that's green area index that's been shown, and there's more bare spots where the oilseed rape only farm standard was shown in the centre, but you'd expect that at establishment. So we had to look further into it. Next slide, please. So looking at how we approach this as a method on farm, the oilseed rape was sown at the 7th of August after a winter barley crop. It was a hybrid variety in Vigour 1035, and was showing the green area index in September there, showing that there was more companion crop and bare patches than conventional. But did this actually work? Next slide, please. So monitoring work was carried out over the course of August through October. So I dutifully went out and monitored yellow water traps across each treatment. And throughout August to October, I only found 2 cabbage stem flea beetles. What we did find was lots of turnip flea beetle and slugs. They weren't in the slugs weren't in the water traps though. I'll point that out. What never put us off was that we were seeing other things happening. So we'd assessed other performance indicators of the oilseed rape performance. So looking at establishment, our aim with hybrid seed was for 50 seeds per square metre. We were wanting at least 20 seeds plants per square metre to have established to gain a decent stand, a decent canopy. So both treatments actually did achieve this, but we could see that there was an uplift of 54% establishment when using the cover crop as compared with the oilseed rape only, which I couldn't believe until I actually saw it with my own eyes. So there was around 22 plants per square metre in the conventional farm standard and 33 in the companion crop establishment. The other thing we looked at the same time was leaf area loss. So looking at predation of the winter oilseed rape only, I should say that for both of these, this is just looking at the winter oilseed rape and not the companion crop. So that's not counted as an extra. Looking at leaf area loss, the companion crop was there. It distracts from the oilseed rape, almost like a trap crop, but to reduce predation. We were seeing that an oilseed rape only was around 10% damage, as compared with a companion crop, which was around 4%. It was 62% less damage when providing a feeding distraction, as I call it, with companion crop for slugs. Next slide, please. So the benefits of the agroecological approach were shown agronomically, but the hub wanted the economics to be evaluated too. So looking at the conventional farm standard here in green, counting up the overall cost of establishment, it was £283 per hectare. And in blue, with the companion crop, which here is as NTRAP, there's an extra seed cost, but you're saving on the fertiliser and pre-emergence herbicide, so it comes to £128 per hectare. And that £155 per hectare difference means that there was less cost to establish to come to, in effect, a better outcome for establishment numbers with the companion crop. It meant there was less risk at establishment financially. Next slide, please. So we see this as a success story, even at that stage, but the full story can only be told once you've then taken yields into account. So yields had to be checked. So using a check weight on the combine, we didn't have a yield monitor. So what we did was we had a measured area in each treatment, and then we collected what was harvested off that area and weighed the boxes. So the outcome of that was that it was similar yields. There was 4.44 versus 4.43 tonnes per hectare. And I'm sure that it was because there was a bit spilled when we first tried to catch it in the box. So we've shown that we've achieved our objectives in this in-field comparison because we've reduced our inputs, we've had our cost savings, and we've maintained our outputs. So this was the overall aim, and that's why it was a great example of how we can achieve these benefits of agroecological approaches through the project and on farm to prove it in context. So one last slide just to wrap it all up, and I quickly touch on the future of the project as it ends in March. The hub does continue with the group remaining in contact through the WhatsApp group, and we're in constant communication on what we'd like to do, what maybe we could do in future. And we'll carry on the good work with our involvement in likes of the IPM Net pilot year, which is shown here, through ADAS, which is DEFRA funded, similar to the yield enhancement networks, but for IPM. And I'd encourage anybody to join that if they were interested. Through the James Hutton Institute, we're also a part of the Sustainable Farm Networks, led by Harper Adams, and it's a great initiative linking a collective to share and their knowledge exchange and focus on farm-led research. So really excited to be part of that as well. And of course, how could I miss out the LEAF network? Because the James Hutton Institute is a LEAF Innovation Centre too. So that concludes the presentation today. So thanks for your time. Happy to take questions, or even if it's in the chat, and I'll pass back to Dan.
Fantastic. Thank you, Andrew. That was amazing. I would just like to say, if anyone does have any questions, pop them in the Q&A, and we'll try and leave some space for the end of the talk, and we'll go through questions in a dedicated space. Amazing. That was fantastic, Andrew. Thank you. Okie dokie. So now we've got Rosemary. Put your slides up there. Just get on the screen share again. Okay. Okie dokie. Over to you, Rosemary, from Warwick Crop Centre.
Okay, brilliant. Many thanks, Dan. So yeah, a slight change of, I guess, cropping system. I'm going to take a forward look at IPM, and I'm going to focus on vegetable and salad crops grown outdoors. For those of you who don't know me, I'm Rosemary Collier, and I come from Warwick Crop Centre in the School of Life Sciences at Warwick University, and we're also a LEAF Innovation Centre. Next slide, please, Dan. So probably I don't need to say what IPM is for this audience, but this on the left is one of my favourite definitions. So which emphasises that it's a decision support system. So you need to think actively about it, about pest control tactics, and it's about integration, and it's also the sort of thing Andrew's been talking about. It's also should be based on cost benefit analyses as well, so that basically, yeah, you're improving your pest management, but you're also maintaining an economically viable crop. So I sort of usually represent IPM with the IPM pyramid on the right, and this IPM pyramid came out of another EU project, the Smart Protect project, which was, I think, for some of the time running in parallel with IPM Works, and had some of the same partners. And one of the reasons why I like the pyramid is basically the emphasis it makes about prevention at the bottom of the pyramid. So that's the sort of biggest block, which is about all the things that you should think about when you're planning to plant or sow your crop. And obviously there are other ways of presenting IPM, and Andrew used a circular representation, which I think is what Leaf generally uses, isn't it? So next slide, please. So why do we need IPM? Well, I think in terms of conventional production, so production where pesticides are used, then to me, one of the key drivers, which is getting more and more urgent now, is the diminishing range of pesticides, so silver bullets. There's also an issue around pesticide resistance, and that will become greater as the sort of range of pesticidal tools available diminishes. And obviously, there are also the environmental aims of IPM, so of trying to reduce the use of synthetic chemicals. If you look at the graph on the right, this really sort of came home to me a few weeks ago. So this is the most recent pesticide usage survey report for outdoor vegetables, and I've just chosen leafy brassicas, and it's the area treated with insecticides. And I just divided by colour into those that you might target at aphids, those you might target at caterpillars and pyrethroids, which obviously are used or can be used against a range of pests. But in the case of brassicas, there are a whole range of pests now that have resistance to pyrethroids. So yeah, there isn't much use in using them much point in using them against those pests. And then why there is concern is that the most widely used aphicides, pyrotetramat, you can see the big pale green area is going imminently in the EU. We're probably going to have it for a bit longer in the UK, not certain what will happen in the future. And then the most widely used insecticide against caterpillars, which is, where's it gone? Indoxacarb, that is going soon in the UK. So you can see that, you know, the choice is getting limited. So obviously organic growers are also already functioning without synthetic pesticides, and you know they are already probably practicing IPM. So we've got something to learn from that. And I guess the constraints in terms of conventional production are that it needs to be intensive production because of you know the customers, and the quality standards that people need to achieve are pretty high. And overall, people need to get the best out of the tools available, whichever system they use. Next slide, please. So this is just a few thoughts really about the future in my view, and what's coming down the track. So first of all, as I've already said, I think there'll be fewer silver bullets, fewer synthetic pesticides, and I think we're bound to need more knowledge intensive approaches, which is sort of inherent in the definition of IPM. There are definitely new tools coming along, so which will mean that there'll be more real-time information for farmers and growers, so things like imaging, AI, robotics. And again, back to the IPM, greater integration of different tools and approaches will be essential to make up for the lack of silver bullets. Great that we've already had a presentation on companion planting, because I think we really do need to give diversity in cropping systems a chance. And my personal view is that we're not going to be completely successful unless we really increase the emphasis on plant breeding and looking for traits of pest and disease resistance that then get bred into varieties. Next slide, please, Dan. So what I'm going to do is just briefly talk through five themes. So I've just listed them here, and I'll just talk through them now. Next slide, please, Dan. So first of all, I think, and again, that's integral to IPM, is about knowing your enemy. So there is every reason to continue using different approaches to in-crop monitoring, both pests and pathogens, and forecasting where that's available. In the Smart Protect project, we looked at a whole range of smart tools, and this is a smart trap in this case for carrot fly. I think we also still need to understand more about pest life cycles, and from my point of view, about whether we can predict more accurately which are going to be good and bad years for particular pests, which might be aphids or might be years when diamondback moth come in. Another, I think, more and more critical factor is trying to work out where our pests and pathogens are coming from, which may mean choice of location for a crop, or might mean working with your neighbours in the future. And I think two areas that I'm involved in, one is bean seed fly. We need to know more about where that comes from, how large numbers build up, and another one is virus in carrot, and where virus is harboured and comes from. Next slide, please, Dan. Then moving on to improving biocontrol, and in this I'm going to include releases of invertebrates and also biopesticides. And at the moment, these tend to work best in protected crops, and that's because of confinement, so in greenhouses or polytunnels, and because there's usually better environmental control. And not silver bullets, so maximising their performance needs thought and care. And biopesticides were the focus of a couple of AHDB horticulture projects, the Scepter Plus project and then the Amber project. And the Scepter Plus was looking at new products and new uses for existing products, and Amber was exploring the application of biological products. And obviously those projects are no longer ongoing. So my question is, how can you build on these? Next slide, please. So just to emphasize that fungal biopesticides do work, but they can vary in their performance depending on the product, target, how they're applied, and the environmental conditions at the time of application. And just flag up how important application is. Amber really demonstrated that with biopesticides, they need to make contact with the pest, so how you apply them is critical. And this week there has been an AAB meeting about the application of biopesticides, so it'd be interesting to hear what the outcomes were. Next slide, please. And on to the potential for increased plant diversity. Well, I think, you know, when you reflect on modern agriculture, then monoculture has actually been one of the problems. And so I think it's really valuable to think about ways of increasing diversity within the field. So there may be opportunities for flower strips, margins for companion planting, which we've already heard about, maybe for trap crops, so areas of more attractive plants that actually draw pests away from the crop. And I think, I mean, people can tell me differently, but obviously they do have additional costs, I guess, in terms of establishment and the land they take up. But I think there are a few disbenefits, really, of trying them out. And these are certainly from conversations recently with researchers in continental Europe. There's certainly current areas of research interest in Europe. Next slide, please. And we just had one opportunity recently to start looking at an approach in lettuce, and that was funded in a relatively small BBSRC project, to which the members of the British Leafy Salads contributed and also took part, and 4 grower businesses did some fantastic field trials. And we were looking at different ways of increasing diversity. So we were planting alyssum with the lettuce to try and increase the visits by hoverflies. We were using brassica plants, so in this case cabbage, as a trap crop for Mysis persicae, because Mysis persicae prefers brassicas to lettuce. And then we were also investigating, but only here at Warwick Crop Centre, the use of barley as a companion. And we've got some, I mean, sadly, aphid numbers were not high that year, so we haven't got very sort of distinctive results, but certainly certain approaches are promising, and I think from other people's work as well, that barley, for example, is an interesting avenue to pursue. Next slide, please. And then on to host plant resistance, and as I said, I believe plant breeding is critical, and so we have a large project funded by DEFRA, which is led from Warwick Crop Centre, the Vegetable Genetic Improvement Network. Harper Adams and the Met Office are partners, and we also have a network of stakeholders. And basically, we're looking for traits in collections of plants from the UK Vegetable Gene Bank, which is also here at Warwick Crop Centre. And we're looking for traits such as resistance to current lettuce aphid in lettuce. And then my colleague John Walsh, shown here, he has both with VegGen funding and with BBSRC funding identified multiple resistances to turnip yellow virus. So I think there's a lot of potential, but obviously the timescale is quite long. Next slide, please. And we also think that it doesn't have to be full resistance, that there's also value in partial resistance. And this is some data from a PhD project by Andrew Gladman, who now works for ADAS. And basically, he was working on cabbage aphid, just showing that through partial resistance, you can reduce the population doubling time of aphids. Next slide, please. And the reason particularly why I think partial resistance could be useful is because of integration, and Tom's going to speak more about integration in a minute. And so basically this is just a representation of how you might stack or integrate different tools to start achieving the same impact, perhaps as an effective synthetic insecticide. As I say, it's only a demonstration of the effects. So next slide, please. So where are the tools and the information going to come from in future, particularly now there is no longer AHDB horticulture? Well, I think sources of pest and disease resistance, obviously from seed companies. And yeah, please, if you have any thoughts about where we should be heading, become a VegGen stakeholder. Biocontrol companies working actively, have lots of useful information, take part in projects and trials if funding's available. What about information from overseas? I'm now talking to a network of European researchers, and we're trying to focus on management of aphids in vegetable crops. And lastly, I think you need to keep an open mind. Many ideas probably won't work, but a few may, and we need to hang on to the ones that work now. So I'll stop there. Next slide, please, Dan. Yeah, just say, yeah, thank you to the research funders, the growers, to university colleagues, and to Leaf for hosting this event. Thank you.
Thank you, Rosemary. Amazing, amazing. Yeah, I would just take this opportunity to say the connections are quite deep, as you can probably tell from Andrew and Rosemary's talk. We're connected. Same with Harper, Tom at Harper. I'd say the IPM space is quite an active one. A lot of innovation and new thinking going on. So if you did want to reach out to any of us, I'd say reach out to any of us, and it will reach the intended recipient. And with that, I'll find Tom's PowerPoint and we'll get him going. So look. Okie dokie, over to you, Tom.
Brilliant. Thanks ever so much, Dan, and thanks for the invite to speak this afternoon. I'd like to take a bit of a step back in this section to think really about whether we're getting the most out of IPM. Andrew and Rosemary have given really good examples of how IPM can be used effectively. And that's absolutely true. But what I want to highlight over the next few slides is whether we can actually do better by thinking about better integration of the tools that we have available to us within an IPM program. Next slide, please, Dan. Thank you. So the first bit, I mean, I won't dwell on this because Rosemary's already really clearly covered the concept of IPM, other than to say that we're very familiar with IPM. There are many definitions out there, perhaps too many definitions, and that can become a problem in its own right, whether we can agree on a definition or not. I mean, I've given an example here of a definition by Stenberg back in 2017 that IPM can be considered as a holistic approach or strategy to combat plant pests, diseases using all available methods while minimizing applications of chemical pesticides. And you'll see that in the various definitions, they, to a greater or lesser extent, they capture many of those points that Stenberg included in his definition. Next slide, please, Dan. Thank you. The bit that I wanted to highlight, though, is that whilst we can agree on what IPM is, and there's been a huge amount of work in developing IPM tools and strategies, what there hasn't been really anywhere near as much has been the development of the science of IPM. And again, Stenberg defines the science of IPM as the systematic study of compatibility and optimization of simultaneously implemented actions associated with at least two pest management elements of the IPM pyramid. So thinking about the pyramid that Rosemary has just shown us, really the science of IPM, what we should be doing is combining those tools in a better approach that doesn't simply bring two tools together. We're actually integrating them so we get more than the sum of their parts, so that they're working in tandem with each other rather than simply bringing those tools together and just adding one to another one. Next slide, please. So most of the research, as I've said, has focused on individual plant protection products that can be considered to be IPM in their approach, that they're IPM compatible. And so we've seen this relatively little amount of research where we've considered how we can integrate these approaches. And so that means that we're combining very often and not integrating these pest management approaches. And that's a shame, because it means that those tools are good and they work, but they could be working more effectively. Next slide, please. Thank you. So if we can combine, and better still, if we can integrate these IPM methods effectively will get these benefits. But currently, that's actually not being investigated so much by the researchers, people like myself. It's actually being developed by the end users, the farmers and growers, who are obliged to take the various tools that they have available to them and to apply them and hopefully integrate those to the best of their ability. And we see some good examples of some farmer-led research where this is happening. And of course, now within the SFI program, we're seeing IPM programs being promoted. And without getting into that in any detail, we can think of that as being a good thing because people are thinking about IPM programs. But clearly, within those IPM programs, we're not capturing whether the tools within the program are being integrated or simply just combined in an ad hoc way. This matters because it means that an IPM system that's working on one farm in one particular year, for example, can often be hard to translate to another system because we don't understand how those tools are interacting with one another. There's a lack of underpinning knowledge of how these methods work and how they interact, and that's can be a real problem within IPM tools. And then as we seek to integrate them, if we don't understand how they're working and how they're integrating with one another, it's very hard then to apply one IPM program to a new system, because we don't know whether it's going to be effective, because we don't know how it's working. We only know that it does work in that situation at that time point. And as a result, we often get the perception that IPM is complicated and unreliable, and that needn't be the case. So if we can have that underlying knowledge, then we can be much more robust with our IPM programs and apply them more reliably and predictably with a known outcome. Next slide, please. So thinking about integration of these tools, I've kind of alluded to this already, but IPM tools can interact with each other in essentially one of three ways. They can, at its worst, at the bottom there, they can have an antagonistic effect. So you have 1 + 2 = 1, so you get less than you're expecting when you bring these tools together. You can have a straightforward additive effect, 1 + 2 = 3, so they're working as we would have expected if we'd been using them individually. But what we're striving for and what we're trying to achieve is a synergistic effect where we have 1 + 2 = 4 or more. So we're getting more than we would have expected from the combination of those IPM tools. Next slide, please. So that's the objective, and that's the aspiration, is to get these synergistic interactions working in IPM. But how do we know that we're seeing synergism? It's undoubtedly happening in many IPM programs, but we don't have reliable ways of recording when synergism is actually happening. And there've been various attempts within IPM to study synergistic interactions, but there hasn't really been one approach widely adopted. So there's no standard that we currently work to. However, if we look to other areas of science, particularly pharmacology, where we have the development of medical treatments, we see actually that synergism is regularly looked for, and they have systems to record when synergy actually happens. And that's through a technique, amongst others, called the checkerboard approach. And so we've been looking at Harper Adams over the last couple of years of whether we can apply the checkerboard approach to IPM. Next slide, please. Thank you. So the idea here at its simplest is that if we took two IPM compatible tools, two biopesticides as a convenient starting point, we can do something that we're very familiar with, where we can vary the concentration of the two the two biopesticides, in this case, a natural pyrethrum and oleic acid. Oleic acid is found in olive oil. And both of them can be used effectively as biopesticides, one of them affecting the nervous system of the insect and the other having a physical activity. And as we increase the concentration of both of these biopesticides, so we increase the mortality the target organism. So this is something fairly standard that we would do. So next slide, please. However, what we can do then is to take this a step further. Within the checkerboard approach, we can look at what happens if we combine those two biopesticides that work in very different ways, and we apply them together, but we vary the concentrations of the two components. And so I made myself very unpopular by suggesting that somebody did this, which meant 67 treatment combinations. But if we do that, we can see if there is a point where we get either additive, antagonistic, or synergistic interactions between those two tools that we're applying. So the question we're asking, at each of those combinations of concentrations, do we see better than expected control, or in this case, insect mortality, than we would have if we'd applied those two elements individually? So next slide, please. And the exciting thing is that, yes, you do see variation in the strength of response, the effectiveness of these two tools. So you can see in the color coding here that generally on the right and lower portion of the grid, we have additive effects. As we move towards the left-hand side, we start to see the pink of synergistic effects, and at the top we see antagonistic effects. So you can see immediately that there are particular areas where combinations of perhaps lower concentrations of oleic acid and lower concentrations of the natural pyrethrum are giving us better results than we would have expected based on their individual components. So that's really exciting. Also shows us that where we shouldn't be going, with higher concentrations of the pyrethrum and medium to higher concentrations of oleic acid, would probably not be a great idea in this case. I should say that we chose oleic acid and pyrethrum not because of any prior understanding, but just simply to test the approach out here. Next slide, please. But having gained some experience of this, we then looked at another aspect of biopesticides, which is that we know that biopesticides are often have the potential to be effective, but they lack persistence and often need to be applied multiple times compared with a synthetic pesticide that often has much stronger residual activity. And so, starting on exactly the same way, we have three bioinsecticides, and in orange we have a synthetic insecticide as a comparison. But you can see that in each case, as we increase the concentration of the bioinsecticide, so the efficacy of the product increases, again, just as we would have expected. Again, these are bioinsecticides all acting physically, so just different modes of activity, but broadly all having physical activity against the insect. Next slide, please. If we add the second element here of the frequency, or the number of applications rather, we can see, as we might expect, that as we increase the number of applications, so again, the efficacy increases. We were able to control a higher proportion of the pest population. Again, very much as we would have expected. But the question then is, just like before, what happens if we vary both the number of applications and the concentration of application? Is there a sweet spot where you get better than the expected level of control? So next slide, please. And again, the answer is yes. As we have higher numbers of applications from medium to higher concentrations of this is for one of the bioinsecticides, you can see that in the main, you're getting synergistic interactions. Whereas if we have fewer applications, we're getting an additive effect, and fewer applications and high concentrations of the bioinsecticide, we start to run into antagonistic effects. So not always immediately intuitive, but you can clearly see here, again, a grouping of responses where we are generally seeing either additive or generally synergistic responses, and other areas on the grid where we're seeing mainly additive or in some cases antagonistic responses. So again, it's pointing us in the direction that we need to be focusing if we're going to get synergy between our IPM tools. Next slide, please. Thank you. So We can see that the checkerboard approach that we've adopted from pharmacology, it seems to provide us with a useful tool in seeing where we can find synergy with the use of our IPM tools. But that seems to work most obviously where we're varying the concentration or the frequency of application. Where things get more difficult is when we think about other aspects of IPM, where we're thinking about varietal selection, biological control, landscape effects, rotations, and so on, all really important within IPM. And they're going to require further adaptation of the checkerboard analysis of the data in order to reflect those in a meaningful way. 67 treatment combinations for the first experiment. That's going to get very expensive when we look at some of these landscape effects, rotations, for example. So we need to think about whether we can collect this data in a cost-effective way. And it may be that a citizen science approach is the way to go here, where no one research organization is going to be able to look at those combinations or all of those combinations on their own. And then the final point there is it enough to see synergy if we still don't know how that synergy is working? And that's the elephant in the room here, that we're seeing synergy, that's great, but we don't know why we're necessarily seeing synergy. So we still have this gap in our knowledge to explain what's actually going on. Next slide, please. And so just to conclude, I mentioned at the beginning that we're familiar with integrated pest management and the term IPM, and that's because it's been around for 52 years now. It's not new. And we've seen much progress in this area with effective IPM programs being developed, but they're being developed without this corresponding development in the science of IPM. And indeed, the science of IPM, as I said at the beginning, is mainly being practiced by farmers and growers who are integrating as best they can the tools that they find that they have available to them. But the scientists aren't necessarily supporting that work and that effort because we don't have the tools to see where synergy is actually occurring or not currently. And so we can identify synergy using the checkerboard approach, but we really need to have that mechanistic understanding together with our ability to find synergy to unlock the full potential of IPM. Thank you very much for your time this afternoon. Just to highlight the work of Joe Roberts, Amy Tonks, and Elvis Garcia, who did the actual work on this piece of research behind the scenes, doing all those treatment combinations. Thank you very much.
Fantastic. Thank you, Tom. That took me back to when you were lecturing me at Harper, actually.
Hopefully not sort of cold sweats and
oh no, it's joyful. Okie dokie. So now that we're all done with those fantastic talks, I think it's time to turn the audience onto the panelists in the Q&A session. So I'm going to hand over to my colleague Sophia to deal with the Q&A.
So thank you, Dan. As a quick introduction from myself, I'm Sophia. As Dan mentioned, I work for Leaf as well, and I've been helping him on the IPM project over the last couple of months. So remember, if anyone does have a question, please feel free to use the Q&A function or just simply type it in the chat box as well, and I can refer that on to the appropriate speaker. But I thought I'd start us off with another question to start rounding off the webinar for anyone that might be considering how to implement IPM themselves. And this question goes to any and all of you three. Is what would your top advice be for anyone that's considering implementing IPM methods more or might find it a bit daunting? What would your top advice be for anyone that might be struggling to grasp or introduce the concept? Open to everyone.
I suppose I'll pop my head up above the parapet first then.
Andrew.
So if you're not sure about IPM methods, but you would like to find out more and want to try some yourself, perhaps to reduce pesticide use, I look at it as reducing costs, if possible. It's to get on board with your advisor, because most farms for sure will work with their agronomist and take on board what their agronomist is saying. So that's the first port of call, is you need to trust in your agronomist, and you need to trust that they're doing the right thing for you and for your farm. The farmer, when you go on farm, as a researcher and from a research background, we're not the experts on that farm because it's relevant to the context of the farm. So it's making sure that the advice is relevant to that context. So
definitely, I think that's perfect. I don't know, Rosemary or Tom, if you have anything to add, but I think Andrew's made a really good point there.
Yes, certainly engage with agronomists. I think if you've got the opportunity, try it out on a small scale first to build your confidence. Yeah,
I'd certainly agree with that point, to try things out before you commit to, for the farm-wide adoption, but also to be patient. But sometimes the adopting IPM practices, you may not get an instant response. That as you're transitioning away from maybe high inputs, it might take a year or two for biodiversity, for example, to start to respond. So patience, it can be important.
Yeah, cool. Thank you, three. I thought that'd be quite useful for anyone considering delving deeper into it. We do only have a few minutes left. I don't want to keep you all for too long. And I don't know if you have any questions you wanted to get in before we finish.
Yeah, I've been thinking a lot about what you said about the mechanistic approach there, Tom. I think what would be the main barriers? I'm trying to understand working at scale, expanding to scale, and what Andrew just touched on there about local context. How much of a mechanistic understanding do you think is the minimum threshold for trusting the process? Would you say we need to go 100% understanding, or just once you see it working, apply it?
I think it depends what we're trying to do, and I think my intention by saying that wasn't that actually from a grower perspective, I don't think you necessarily you have to have that mechanistic understanding. I think you'll have a feel for what's working and what's not working. I think I'm coming at it from, if we're trying to be researchers or advisors, we kind of need to understand why we're saying what we're saying better, so that we can reliably give information in different situations and understand what the likely outcomes are going to be. Andrew already made the point that you need to understand your specific situation, and each grower will know that. But then if we're going between different systems, but we don't really understand the mechanism, you can run the risk of giving advice that maybe doesn't work in that situation, because we didn't really understand what was going on fundamentally.
Yeah, fantastic. Okay, I think we've got one from Alex here. A question for Tom, please. In practice, how do you think that we can achieve synergistic effects of products applied for control? Do you have any suggestions, please?
I mean, at the moment, I think people are, and I asked this recently at a meeting, for whether the growers felt that they were seeing synergy, and most growers felt that they were. I think my concern is we have no way of actually evidencing that. So you see a good outcome, and that's great. That's not something to be, it's not a problem, but we don't actually know whether we've got synergy there, or whether we would have had the same outcome just by combining those tools. So I think there's no quick answer to that, because I don't think the tools are out there at the moment to allow somebody to do it. And also in the standard crop situation, you're not going to have a control to compare with, so you're not going to know easily whether you've got a better outcome than you would have otherwise. So I think my comment would be to be inquisitive, and not accept that what you're seeing is as good as it can be, but you can potentially push things further, and not to sort of rest on a good outcome, because that good outcome may be on the way to an even better outcome if we can tweak things. So I think just be always inquisitive. This is good. Can I do better?
Fantastic. Thank you. Okie dokie. So I don't know if anyone has any more questions. Maybe just a last shout to pop it in the Q&A if you do. Give you a little 10 seconds. Just any last thoughts? Okay, well, if not, this has been recorded. I'll send it around to everyone. I'd just like to say a huge thank you to all of our speakers, and thank you for everyone who popped along and watched this. I hope you found it valuable. And feel free to reach out by email. I'll pop that in the chat as well. And I think that'll be it. I think we'll end the call here. Thank you to everyone and enjoy the rest of your day.
Thank you so much, guys. Thank you.
Thank you, everyone. Take care.
Bye.
Thank
Bye-bye.
you. Bye.
Bye.
Thank you. Bye. Bye.